Good morning. Today I will explain the 01 knapsack problem using the dynamic program. So the problem is that write a program that selects a subset of items that has maximum value and satisfies a given weight constraint. So you have to maximize the value, but the constraint given is that the constraint given is of weight. All right. What is the meaning of 0, 1? 0, 1 means no splitting. No splitting means we have already covered the fractional knapsack problem, but this will be a 0, 1 knapsack problem. For example, there are some items available like item 1, 2, 3, 4, and item weight is 5, 3, 2, 1. In the fractional knapsack problem, we were doing that we were taking the fraction of the item also. But in 0, 1 knapsack problem, we cannot take the fraction of the item. We will have to either take the item or reject the item. We can't take the fraction out of it. So we solved the fractional knapsack problem using the greedy approach. That's what I have written here. 0, 1 means no splitting. No splitting means we cannot take the fraction out, and we can't take fraction out of item. Splitting or fractions means means we can solve the problem greedily, and that's what we did earlier. The fractional knapsack problem, I explained you that how to solve it using the greedy approach. But now we will deal with the 0, 1 knapsack problem, and we will try to solve it using the dynamic programming approach. Now, if we try to solve, so what is the problem at hand? The problem at hand is that we have to find out a subset of these items. The maximum weight of a knapsack is 5 kg. Knapsack is a bag only. We have to put the items, but the maximum weight of that bag can be 5 kg. For maximum items we can put, total weight can be 5 kgs. But we have to maximize this profit. Profit means the value in dollars. All right. This is the constraint of 5 kg maximum weight. If we try to solve this problem using the brute force approach, so what is the time complexity of the brute force approach that we have to consider for every option? Every combination, the time complexity is exponential, and this is O to the power O of 2 to the power n. So we have to find out an approach which can solve this problem in an optimized way, right? Taking some lesser time. Now the question here, the most important question. See, I have tried to explain you the 3 approaches. One is greedy approach, the divide and conquer approach, and the dynamic programming approach. I will solve this problem. That's not an issue. The question is that you have to understand what is the dynamic programming approach in this problem, right? Which we used. Now, the first requirement of the dynamic programming is that you should be able to divide a problem into sub-problems. So that's what I'm trying to explain here. Do you see the potential for sub-problem? Because that's dynamic programming. What is dynamic programming? You have to identify whether a given problem can be divided into sub-problems. And this is also divide and conquer. But how divide and conquer is different from dynamic programming approach. In dynamic programming approach, we should be able to remember the answers to previous solutions of sub-problems. If you remember the problem of memoization, we stored the values of the earlier calculated results, and we used those results for our future solutions. So that is dynamic program. That's how dynamic programming is different from divide. I have already explained these things in detail, but still I wrote in my notes so that the things are revised. And so this is the problem of 0-1 knapsack, right? And you have to basically identify first of all whether this problem can be divided into sub-problems. That's number one. Number two is whether you can overlap the results, meaning by that some previously calculated results if you can use. Okay, so let's try to enter into the problem and let's see what is the solution. Okay, the total, now this is from the explanation point of view, right? That at the start, what is the weight left to be put in the knapsack? That is 5 kg. Of course, that is the maximum capacity. Possible choices are item 1, 2, 3, 4. These are the weights and values given for the items. 5 kg is $60. If you select item 1, it will weigh 5 kg, but it will give a value of $60. So item 2, 3 kg is $50 and so on. To start with, what is the value available? The value available is $0 because no item is put in the knapsack. The weight we can put is 5 kg. That's what the writing, whatever I have written, that's the meaning here. To start with, initial conditions, you can say. Now, what is the choice? The choice is that if I select item, choose item 2, let's say I choose item 2, which is $50 and weight 3 kgs. So what is left? What is left weight? Left weight is only 2 kgs because the maximum capacity is 2. Out of the 4 items, I can select only item 4, right? Item 4 can be picked. So what is the total value addition? Total value available is $80, right? If I select, the point that I'm trying to explain is that if I select item 4 and item 2, the total weight is 5 kgs. Done. What is the value available? $50 plus $30. So total value is 80. This is one sub problem. Please try to understand why why I have taken this one example. This is one sub problem. So I definitely see a potential of dividing this problem, the whole problem, into sub problems. That I can select certain combinations and I can make the total weight as 5 kgs and I can get some value. That means I can divide the whole problem. I can have some other combinations also. This is one of the combinations. This is one of the sub problem. And this is the solution, of course. But this is one solution to one sub problem. What I'm trying to say is that first condition of dynamic programming is met when we say that the whole problem can be divided into sub-problems. The sub-problem, one sub-problem I have explained. I will explain further sub-problems also, and we will make a tabular. We will make a table also, and we will try to solve this example using a tabular method, right? So when we choose an item, we lose. So when we choose an item, suppose I chose the item number 2. It weighs 3 kgs and the value is $50. So choosing an item, we lose the choice of items. Losing the choice of items means when I chose the item number 2, so I cannot select item 3 and item 1. So I lose the choices here. Because when we choose an item, we lose the choice of items because we have the constraint of weight. Of course, we have the constraint of weight. The total weight cannot exceed 5 kg. Definitely, this is an optimization problem. Meaning by we have to optimize the solution so that we get a maximum value. We cannot keep on choosing the items. That's a brute force approach. So this becomes an optimization problem. We have to apply an optimization technique, and our optimization technique is dynamic programming. All right. And I have also explained that this problem can be broken down, can be divided into sub-problems. I have already explained you one of the sub-problem, and this is the solution of that to that sub-problem. All right, because this is an optimization problem, because we need to know the answer of other sub-problems that we solve. Right. So this is an optimization problem, and this fits into dynamic programming approach. Let's try to solve this example. Now, we will use the bottoms-up approach. We will start from the bottom when we solve it. I will explain to that. But let's try to, before I come to this problem, I have one more problem. Similar, solving the, solving the knapsack problem. Let's look at this problem first, because why I'm taking this problem. I will come back to that problem, no problem, because I have written down the formula also. But before going to formula, we will try to solve it by looking at the values. So I have little bit changed the question. The question is now, the maximum weight available is 8. Maximum weight of the knapsack can be 8. Items are 4. These are the profits associated with the item, and these are the weights associated with the. This is the weight set and this is the profit set for 4 items. Maximum weight of the knapsack can be 8 kgs, or let's take the weight units as kgs. So these are the items 1, 2, 3, 4. These are the profits I have written as available in these sets, and these are the weights 2, 3, 4, 5. Now let's look at how this table can be constructed. How many columns I have to take? This portion is redundant, so don't consider this portion. How many columns I have to consider? I have to consider, because the maximum weight is 8, I have to increment the weight in ones, zeros and ones. So this weight is this 0 means if the maximum weight of the knapsack is 0. This 1 means if the maximum weight of the knapsack is 1, 2, 3, 4, 5, 6, 7, 8. Because the maximum weight is 8, therefore we have taken the columns from 0 to 8. No weight, 1, 2, 3, 4, 5, 6, 7, 8 up to 8. And how many rows are to be there? Number of items. If 0 item is there, 1, 2, 3, 4 items are there. All right. Now, if the 0 item, let's try to fill the entries. If the 0 item is there, right? So this row has to be 0 basically, because no item means no weight can be added into the knapsack, and this will also be 0 because the maximum capacity of the knapsack is 0. So that means we cannot. If you look at the column 1, the capacity of the knapsack is 0 kgs. That means we cannot enter any item into the knapsack. So all zeros. And if you look at along the rows, so that means no item can be put. So all zeros along the first row and the first column. So let's try to look at the this entry, row 2. I mean corresponding to, I will call these rows, row 0, row 1, 2, 3, 4, like this. So let's look at the entry of row 2 and column 2. Row 2 and column 2 says me that the maximum weight of the knapsack can be 1. I have no items available where the weight of the item is 1. So I will put 0 here. That is that entry cannot be made. Now let's look at the next entry, row 2, column 3. Row 2, column 3 means the maximum capacity of the, this is for the item. If I am trying to choose item 1, please remember that I am along row 2, I am trying to choose the item 1, and the maximum weight of the knapsack can be 2. What is the weight of the item 1? 2. So therefore I can, what is the profit associated with item 1? 1. So I will put 1 here. All right. So I can put 1 here, and the maximum only, that means along row 2 I am choosing only one item. I am not considering 2, 3, 4 because I am in row 1 only. Please remember that while filling the entries, I am for second row means I am only considering item 1. No items are considered. Item 1 weight is 2 kgs. Of course, this entry can be made because that's the capacity, column 3 capacity. So what is the profit associated with this is 1. Because I am selecting only item 1, so for the remaining also, and I have to choose items only for once. This problem says that I have to choose items only for once. So for all the other entries, the profit available is only 1. So that's why these entries are 1 throughout. Is that clear? Now, let's look at row 3, meaning by that I can select item 2 also or item 1 also. So let's look at, so when the capacity of the knapsack is 0, that means I cannot put any item. When the capacity of the knapsack is 1, I cannot still put any item because no item weighs 1 kg. When the maximum capacity of the knapsack is 1, so the entry to be made is that this is 1 here. Now for item 2, what is the weight? 3 kgs. So that means I can put here item 2, right? What is the profit associated with item 2? It is 2. So I put 2 here because I can select this item, right? Now let's look at the further, if the capacity is 4, I cannot put any item. I will put 2 here because I can only select this item. If the capacity is 5, I can put I can put this if the capacity of the knapsack is 5, all right, that means I can put item 2 also and item 1 also. And what is the profit? 1 plus 2. So I will make this entry as 3. Now I cannot put any other item for any capacity of the knapsack. So this will remain 3, 3, 3 only. Here I am trying to only explain the problem using looking at the weights and profits. I will give you the formula also. You can directly apply the formula and get the values. But let's try to look, and please remember, this is very important. Every cell of this table is a sub-problem, is a solution to the sub-problem. Meaning, what is the solution expected? The solution expected is the profit. And what is the sub-problem? Selecting the items. Every cell of this table is a solution to the sub-problem. Every cell pertains to one sub-problem. Please remember that. Now let's look at item 3, row 3. That means I can select from item 3, item 2 and item 1. I have to consider the previous rows only, not the future row. I have to consider the previous rows. If the capacity of the knapsack is 0, that means I cannot enter any item. If the capacity is 1, still I cannot enter 0. If the capacity is 2, that means I can enter 1, item number 1. If the capacity is 3, that means I can enter item number 2. If the maximum capacity of the knapsack is 3, so I can enter item number 2 with a profit of 2. If the maximum capacity is 4, right, so I can enter what items? Because I can enter item number 3, right, which is having a weight of 4, but its profit value is 5. So I will put 5 here. All right. Now, if the maximum capacity of the knapsack is 5, so I cannot make any combination, the solution is 5 here only. If the maximum capacity of the knapsack is 6, so 6 means still I can't, 6 means what is, if the maximum capacity of the, I can make these combination 4 plus 2. I can select item number 3 and item number 2. So what is the profit associated with item number 4 and 2? 5 plus 1. So I can put 6 here. Well, I have, what value I have to put in the table is the profit value. Now, if the maximum capacity of the knapsack is 7, so what combinations I can make? I can put item number 3 and 2, because I cannot select item number 4 corresponding to row 3. I can, if the maximum capacity is 7, 4 plus 3. That means what is the profit value? 5 plus 2. So I enter 7 here. For 8 also, I will enter 7 here. So what I have tried to explain is the entries corresponding to first 4 rows of this table. Now let's look at this formula, because every entry in the table can be made through the formula also. Now let's look at the formula, and we will try to solve some of the entries in the row 4 with this formula, right? So let's look at it. Now V is, let's call this table as V. So this is the table. What is I? Is the row number. I is the row number. W is the column number corresponding to the weights. What are these weights? The maximum capacity of the knapsack. Though in our problem the maximum weight given is 8, but we will try to see what are the options. If the maximum capacity is 0, 1, 2, 3, 4, like that. So column number pertains to weights. Now how we can get the entry? It is the max of what? Max of I minus 1. I minus 1 is the previous row. Max of items. First value is I minus 1, comma W. Right? Then the second item is V of I minus 1, previous row, W minus WI. The weight, I will explain this, plus profit. Let's try to solve this formula for some entry. Let's try to get this value. 4, 1. 4, 1 is okay. Let's try to solve 4, 1. It is the max of, what is I here? I is 4. I minus 1 will be 3, right? What is W? W means the maximum capacity weight for this entry, for the 4, 1 entry. What is the weight? The maximum weight of the knapsack is 1 kg. So this W is 1. So I am trying to, because I am trying to fill this entry 4, 1. So this is V of 3, 1. This is, I am trying to make the, let me explain once again. I am trying to make an entry for V of 4, 1. What is 4? 4 is the 4th row. What is 1? 1 is the column number 1. This entry. Now let's try to solve this. This is I minus 1. I is 4 here, therefore 3. W. So W is, because 1, it is 1 here, the capacity of the knapsack. So it is 1 here, of course, comma, because I have to select maximum of certain items. So what's the next item? Next item is V of I minus 1, V of 3. Now this is W minus WI. What is I here? I is 4. 4th item. 4th item weight is 5. Now W, what is W? This W pertains to 1. 1 minus, what is WI? WI is the weight of the ith item. What is ith item? This is the 4th item. What is the weight? 5. So that is why it is W minus W. This W is the weight of the knapsack. This wi is the weight of the item. So therefore 3 comma 1 minus 5. And what is pi? Pi is the profit of that item. What is the profit of this item? It is 5. The profit is 6. So therefore v of 3 comma 1 minus 5 plus 6. So what we say that it is the max of 3 comma. So this 3 comma minus 4, there is no such entry. So we will put 0 here. No such entry is there. So this is a redundant, this is not a valid entry, so we put 0. Let's try to calculate some more values. Let's try to calculate 4 comma 5. You can get any entry by using this formula. V of 4 comma 5, because all other entries will be the previous entries only. So what is the meaning here? V 3 comma 4, this is not a valid entry. Take the previous value from here. So we will take this 0 here, this 0 here, this 1 here, this 2 here, this 5 here. Corresponding to this weight 5, we will see the value now. V of 4 comma 5, that means we are trying to get this value. V of 4, 4th row and 5th column. Let's see how we can get it. This is max of this is I minus 1, 3 comma W is 5 because 5 is the weight of the knapsack, 5 comma V of 3 I minus 1, this is 3. Now what is this W? This W is the weight here for the knapsack, capacity of the knapsack, which is 5. 5 minus what is Wi? Wi is the weight of this 4th item, which is 5. So 5 minus 5 plus 6. What is this 6? This 6 is the profit of the 4th item. What we get is max of 5. V of 3 comma 5. What is V of 3 comma 5? It is 5. This value. Comma. What is 3 comma 0? What is 3 comma 0? It is 0. Plus 6. Plus 6. 3 of, that means 0 plus 6. It is 6. We have to select a max value from 5 and 6. So this value is 6. So therefore this entry comes here as 6. Now let's solve one more value, V of 4 comma 6. This is dynamic programming formula. You know what is dynamic programming? Dynamic programming means we are dividing the problem into sub problems and we are storing the previous values so that we can use for future results. We are storing the previous values and we are using those values as we did in memoization. We are using the same values for our future subproblem. So that is dynamic programming. So let's look at this 4 comma 6. What is the meaning here? I minus 1 means 3 comma 6, because what is this? W is the 6th column, and for this column the capacity of the knapsack is 6. So 4 comma 6, 3 comma 6 here, right? And the next next element is V of I minus 1 is 3, of course. W minus Wi, this is 6. What is this W? This W is 6. What is this Wi? Wi means weight of this item. So 6 minus 5 plus 6. What is this plus 6? Again I am repeating, this is profit, plus 6. So what is the result? V of 3 comma 6. V of 3 comma 6 is 6. So we put 6 here. Now what is this value? V of 3 comma 6 minus 5. That means 3 comma 1. What is 3 comma 1 is 0. 0 plus 6 is 6. So 6 comma 6 is 6. So that is why 4 comma 6 entry is 6 here. So that what I'm trying to say is that you can make an entry into the table using this formula also, because ultimately you have to write a program. So while writing the program, you must know how the entries are being made into this table. So you can use this formula. Only thing, you have to put 2 for loops and you have to make the entries into the matrix. It's a matrix only 2 by 2, 2-dimensional table. So you can make the entries into the table using this formula. Rest of the entries I'm not explaining, but you will get from this formula. And otherwise also, by looking at the combinations, by looking at the different sub problems. Please remember that. That's the most important part. You see, applying the formula and getting the values is not important. You can get it that. You can get that, no problem. But understanding that why it is dynamic programming problem and how we are solving it using the dynamic programming, that's the most important point. And probably I have tried myself to explain you. If you still find any difficulty, you can ask any questions. I took this problem also previously. The same problem is solved using the same method. Right now, let's concentrate on looking at the same problem only. The question is that we have made the entries into the table. Fine. We have made all the entries into the table. We have made how many entries? 8 into 4, 32 entries we have made into this table for solving this problem. But what is the solution? I mean, what is the best and optimized solution for the items to be placed in the knapsack? Let's look at the solution, how to get the solution. Okay, so what items to be put? What should be the final solution? Maximum value is, now if you look at the table, what is the maximum value? Maximum value is 8. If the maximum value is 8, right, corresponding to item 4, please remember, please try to understand, this maximum value is 8 corresponding to item 4. That means item 4 is definitely there. If item 4 is definitely there, that means its weight is 5 and its profit is 6. Max value, what is this max value? This value 8 is the profit value. How much maximum profit we are gaining? Because that was the ultimate problem. We have to maximize the profit. What is the maximum profit in this table? This is 8. 8 is the maximum profit. That means corresponding to item 4. That means item number 4 is definitely there. What is the profit associated with the item 4? It is 6. That means if the maximum value is 8, and 6 is the value of item, and these are the 4 items I have put, x1, x2, x3, x4, and this one I have put corresponding to x4 because item 4 is definitely there. And item 4 profit is 6. 8 minus 6 is 2. Maximum is 8. We have got 6 is corresponding to item 4. What is left? Left is 2. Right? And this one means item 4 is definitely there. Now, so item 4 is definitely, if item 4 is definitely there, what are the other items? Let's look. Now 2, remaining is 2. Look at row number 3. Any 2 is there? Yes, 2 is there in row 3. Does it correspond to item 3? To verify that, let's look at the even previous to 3. Whether 2 is there? Yes, 2 is there in the row 2. So that means this 2 is there for item 2 also. Whether 2 is there for item 1? No. So that means we select item 2. And if you see item 2, weight, item 2 profit is 2. That means 6 plus 2 is, and item 4 weight is 5. 5 plus 3 is 8, which was the maximum capacity of the knapsack. And what is the profit? 6 plus 2. So meaning, what I'm trying to say is that look at the maximum value in the table after filling. So you get 8 here, right? Item 4 is definitely there. Let's look at the previous more items. Go back. What is the left profit value? It is 2. 2 is there in third row also. But does this is this 2? Does this 2 belong to item 3? Let's verify it. How we will verify it? Let's look at the even previous row. 2 is still there because this 2 in row 3 has been carried forward from row 2. In row 2 also 2 is there, right? Is there any 2 in the row 1? No. So that means this 2, profit of 2 has come from item 2, not from item 3. So therefore, I put 0 against item 3, 1 against item 2, and 0 against item 0. So what is the final result? If you select item 2 and item 4, you get an optimized result with a profit value of 8, and these items are to be selected. That's what the knapsack problem is, 0-1 knapsack problem is, and that's how this knapsack problem can be solved. I hope you can. I took this previous example, small example of this also. I have tried to fill the table also. Same method as I explained here in my notes. Basically, these are two problems. One is this problem starting from page number 4, and the other problem is starting from page number 2. Right? Two examples I have taken to solve the knapsack problem using dynamic programming. I finish my lecture here. If you have any questions, you can ask the questions right now also, because I have about 4 minutes left for this meeting. Otherwise, I will starting from Friday, I will take 1 or 2 interactive sessions where you can look into your notes and you can ask questions. I will not, teach anything. Most of the syllabus is done. So I will not teach on Friday, at least I will not teach, and I will take the questions from your side. If you have any questions, please ask. So Friday's session will be an interactive session for your questions. If any questions are there, then please ask, otherwise I will close the meeting.
No, sir.
Okay, thank you. And please stay safe. That is very important. Your lives and your are valued. So please stay safe, remain at home. Thank you so much. Thank you.